Okay guys, today we're going to talk about graphing inequalities. So let's get started right away here. Okay, first one we're going to graph is going to be the inequality y is less than or equal to 4. So if you remember how to graph the equation y equals 4, there should be no problems. Here we go to our Cartesian plane, label your x and y axis. Okay, let's think about what does y equals 4 look like. I hope you said it's a horizontal line. So let's get started here. Now, one thing is y is less than or equal to 4, so y can equal 4. So I'll start here, I'll put a point here, and I'll get a horizontal line going. Now what this means is, every point along here, y equals 4. So that is a solution to this inequality right here. But also, where are the values located where y is less than 4? So think about your Cartesian plane. Would it be in the region above that line or the region below? I'm hoping you said the region below. So really, all these points here, think about it. Any point in this region over here are going to be solutions because y is less than or equal to 4. So this is the way I like to shade. I just kind of draw some lines down from my line. And what that indicates to me is every single point in this region below the line will be a solution to this. Now let's go ahead and graph this line right here. Graph a second inequality. So I'm going to start by graphing line y equals x plus 1. Y-intercept is 1. The slope is 1. I'll go up and over 1 a couple times. Okay? I get a line going here. Now, one thing I have to decide as long as this graphing is, do I want my line to be shaded line, or I'm sorry, do I want my line to be a dashed line or a solid line? Now, by having a solid line here, what it means is that every point on this line will be a solution this inequality right here. So for instance, what I'm saying is this point here, 2, 1, because on a solid line it should be a solution here. If we went ahead and wanted to check that out, plug 2 in there, I'm sorry, so 2, 1. Ms. Woods told me that, by the way. It should be 1, 2. Okay, so for instance, we'll plug a 1 in here for x, plug a 2 in there for y, and you get 2 is greater than or equal to 2, which is a true statement. So every point along this line will be a solution. So anyway, now here we go. We've got the region, we've got a region above the line and a region below the line. Again, we're looking for all the points that are going to satisfy this inequality right here. Now I could teach you a little shortcut, but I'm not. What I'm going to ask you to do is, let's just find a test point. Find a point either in this region or this region above, and let's plug it in and see if it works. I always like to try 0, 0 when I can. So here's the point 0, 0. I'm going to use it as my test point. Plug 0 in here and 0 in here, and we get 0 is greater than or equal to 1. Now if it's a true statement, what that means is that point where the location is going to be one of my solutions. I'll shade that side. But if it's not a solution, I got to shade the other side of the line. And once again, if you look here, this is a false statement, which means this point right here is not a solution. So that indicates if this is not a solution, all the points above this line over here will be solutions. So again, here's how I like to shade. And again, this notation means all the points above a line will be solutions to this inequality. Let's go ahead and do one more here. Hope this will be a really easy one for you. We're going to graph the inequality x is greater than or equal to -1. Now you know what x equals -1 looks like, I hope. If you don't, remember Hoy Vux. So now we've got x equals -1. So now I'm going to go ahead and start by doing this. I'm going to graph a solid line here. Now if you remember what I talked about earlier, what this means is, because we have a solid line, this means every single point along that line is supposed to be a solution. But if you notice here, this doesn't say x can equal -1. It has to be greater than -1. So what that means is points along this line are not going to be solutions. So how I indicate so is by going ahead and just making it a dash line. You've got to be very careful when you go ahead and graph these ones like this where it says less than, or in this case greater than. Okay, so now look in your Cartesian plane here. By the line going vertical, you've got a left side to it and you've got a right side. Where is it where all the points are located such that x is greater than -1? So here's -1, here you got -2, here you got 1 here. Hopefully you said to the right side. So once again, my shading right here indicates every point to the left of that vertical line will satisfy the condition of x being greater than or equal to -1. One more, and then we'll bring on the kingpin, Miss Woods, to kind of show us how it's really done. So we'll start here. Now I got a little trick for you. Maybe you've seen this before. Y is greater than or equal to the absolute value of x minus 1 quantity then plus 2 here. I'm hoping by now that all you guys are getting pretty comfortable graphing absolute value functions. This minus 1 here, where does that control? Horizontal shift. This right here is your vertical shift. So we have to shift to the right 1 and a vertical shift of 2. Your coefficient out front is 1. It's a positive 1. So what that tells you is you're going to go up 1 and over 1 to the right, up 1 over 1 to the left. So here is your absolute value function. Now, have I done it correctly as far as graphing a solid line? Look here, you see the equal sign? It can't equal the points on here. Will be solutions. We have two regions, above it and below it. So let's go ahead right now and decide. Again, there are some tricks to this, but I'm going to start by doing a test point. I'm going to pick this point down here, 0, 0. I say TP is 0, 0. I'm going to check that out. I'm going to plug a 0 in for x here and a 0 for y. 0 minus 1 is -1. Absolute value is 1 plus 2 is 3. Once again, is this a true statement? The answer is no, it's false, which means this point here is not a solution, which indicates everything above this absolute value line curve will be a true state, will be a solution. Okay, guys, that's it. Hope you had fun. See you in class.